All right, we are on to the video for the day 5 notes section, which is about using SOHCAHTOA to find missing angles of a right triangle. Okay, so question 1 there, to find missing angles of a right triangle, what information do you need? So I already wrote this or in here because there's 2 ways we could do this. So if we want to find the 3 angles of a triangle, we could do it using other 2 angles. Okay, so if I know 2 angles, I can find the third easy because in a triangle they all add up to 180. Okay, that's kind of the basic way of doing it. But let's say I only knew we had a right triangle. Okay, I only know one of the angles is a right angle. I don't know the other 2 at all. The way that I can find the other 2 angles is by knowing at least 2 sides. Okay, so we're going to talk about that second way today. So if I know at least 2 sides, and sorry about the light there, that's what that says. I got a shadow on it. Okay, knowing at least 2 sides. Okay, so if I want to use that way, by knowing 2 sides to find the missing angle, I'm going to still use my SOHCAHTOA functions, my sine, my cosine, and my tangent. But to find an angle, I need the inside of the parentheses of those functions. So to find that angle, I need to use inverse trig functions. Okay, so those are going to look like sine inverse, cosine inverse, or tangent inverse. Okay, so let's talk about setting those up. Okay, it's going to look a lot like how we set up the problems yesterday with the sides, but now we're solving for an angle, so we're going to do something slightly different to solve. Okay, so first thing I do, name my sides. Okay, again, you might be able to recognize these pretty quick without actually going through the process of naming them. That's okay. I'm going to go ahead and do it here, give you some good steps to follow. Okay, so first I name this side down here. So I'm across from this right angle. That is my hypotenuse. Okay, this question mark, I'm going to actually replace the question mark with a theta because we like to find theta when we're talking about angles. It still works with a question mark. It's just a variable that we can find. Okay, across from the theta is my opposite side. So that's my OPP. And that leaves the 5 over here to be my adjacent side. Okay, again, don't need that OPP. That was just to label the other side. Okay, now I need adjacent and a hypotenuse, so that's A and H, and that happens with cosine. So I'm going to set up a cosine. Cosine of theta, again, I replace question mark with theta here, equals adjacent over hypotenuse. Okay, and we're going to be able to find that missing angle here because we know at least 2 sides. Okay, from here, I need to get theta by itself. So the way that we get theta by itself is doing the inverse of cosine. Just like if this was theta squared, we do the inverse of squaring or square root. To do the inverse of cosine, we use inverse cosine. So to get theta by itself, I have to inverse this cosine on both sides of the equation. So theta equals cosine inverse of 5 over 6. Okay, now we solve for theta. We're going to, again, round it to find a good degree angle here. And I'll show you how to do this inverse on the calculator, or remind you. So hopefully you've done this before. Okay, so I want to type cosine inverse of 5 over 6. So I see cosine there. Cosine inverse is in blue right above it. So I'm going to hit the second button. So second, it'll show up a little second there to see that I clicked it. And then if I press it, it shows cosine inverse. You're not trying to put like a caret and then -1 there. You're using the actual second cosine button. Okay, and then 5, 6. So I'm going to do 5 divided by 6. Should look like that. And from there I can press enter. And just like we talked about yesterday, make sure this is showing degree because we're trying to find the degree of the angle. Okay. And we'll press enter and we get a nice number. Let's round this to 2 digits again. 33.56. Okay. So theta is approximately 33.56 degrees. All right, last one for the day. Let me focus back in because that didn't show up. 33.56 on that last one. Okay, let's do 3b. So we've got question mark again. Again, I'm going to call that theta. Let's label our sides. Hypotenuse. This one is the adjacent. You don't have to call the other one opposite first. Okay, we've got adjacent and hypotenuse, so we're going to be using cosine again. Didn't mean to pick it so that they were adjacent and hypotenuse on both, but if they weren't, like if I had adjacent and opposite, you're using tangent. If I had opposite and hypotenuse, you're using sine. Okay, so don't worry about that too much. You're just going to end up using a different inverse function when you solve. Okay, so let's write the equation out using cosine again because adjacent and hypotenuse. So cosine of theta equals adjacent over hypotenuse. Okay, and again, trying to get the angle, trying to get the thing inside the parentheses there, so I have to do the inverse. And if I do the inverse on this side to get rid of the cosine, I do it on the other side. And now we got theta by itself. All that's left to do is plug it into the calculator. It's going to look like we did on the second, or on 3a. So I'm going to hit second, cosine, 35 divided by 51. And if you type that in, do it all right, you should get 46.66 degrees. Okay. When you're doing that IXL, be careful that you're not, be careful with the directions. It might tell you to round it. It might want you to find all 3 sides or all 3 angles, but you're going to do great. Just a quick reminder, probably going to have a quiz on Friday over the first 3 sections of this notes packet. Okay, it'll be a short half-page quiz, 3 or 4 questions. Don't worry about it too much. Okay, and open notes as always. All right, see y'all later.